Welcome to Lesson 4 in the Transformation Unit. Lesson 4 discusses the classification of rigid motions. 3 theorems sum up what we know about rigid motions. Theorem 3.3 says the composition of 2 rigid motions is a rigid motion. So if we look at QRST, reflected over, and then rotated up, you can see that it's the same size, same angle measures, same side lengths as what we started with. That means that it's a rigid motion, and another name for that would be isometry. Then we have Theorem 3.4. Theorem 3.4 says that any rigid motion is either a reflection, a translation, a rotation, or a glide reflection. This is the notation for all of those. M is the rigid motion. The first one is a reflection. This is a translation. This is a rotation. And this is a glide reflection. And that's what we're going to be working on today. And then we also have a corollary to Theorem 3.4, which is kind of like something you can tack on. It says that any rigid motion can be expressed as a composition of reflections. So, if M is a rigid motion, then either it's a reflection, or it's 2 reflections, or it's 3 reflections. But every one of the rigid motions can be rewritten as a series of reflections. Okay, let's take a look at the glide reflection. Glide reflection is a composition of a reflection followed by a translation. Let's take a look at this one right here. So if we look at triangle ABC and then triangle ABC prime, you can see that their orientation is different. They're facing a different way, and they're in a different area. So if we kind of work backwards and we slide triangle A prime, B prime, C prime up so that it's even with triangle ABC, we would go 1, 2, 3, 4, 5, which means that we must have, from right here, we slid it down 5. So we can complete that slide, and at some point triangle ABC was right here. Then we can reflect it over. Okay, to see where it's reflected over, let's count the spaces in between these 2 vertices. So we've got 1, 2, 3, 4. So right in the middle of the vertices, a line that would go through all of the midpoints would go right down here through x equals -1. Okay, so we've got a reflection. We've got a reflection over x equals -1. Okay, so ABC reflected over x equals -1. And then we have a translation, which is a slide, moving our figure down 5. Okay, now this is a composition, so that means that we're going to start with the thing that happens second. So we're going to say that this is a translation of 0, -5 inside a composition with a reflection over x equals -1. And this was done with triangle ABC. So this is what we mean by a glide reflection. It's composition of a reflection followed by a translation. Okay, let's take a look at one on the other side. Okay, example 1 looks very similar. So what we want to do here is, first of all, we want to move or slide J prime, K prime, L prime over so that it is lined up so that we can flip it over. Okay, so if we move J prime over to where it is above J, then we would have to move it over to 1, 2, 3, 4, 5. Okay, and then L prime would be right here. And then moving K double prime over would be 1, 2, 3, 4, 5, so it would be right here. So the first part of our glide reflection would place our triangle right about here. Okay, so that means that that was a translation. Our translation was to go over this way 5 units. That's horizontal, so we're looking at 5, 0. Okay, now we've got to figure out where our line of reflection is. So I've got K and K prime, and so I want to figure out where the midpoint is. So 1, 2, 3, 4, so 1, 2, so it looks like I'm going to have a midpoint that goes right through here. Okay, and that is going to be a reflection over y equals 1. Okay, so when we write this, we start with the translation because the reflection is actually what happened first. So it's going to be t of 5, 0, and then a composition with a reflection over y equals 1, and then this was triangle JKL. Okay, so we have another one. So we're really just using a strategy where we work backwards. Okay, let's try one more. Okay, so if we're looking at ABC to A prime, B prime, C prime, then first we want to slide this up so that our vertices are even. So if I'm going to slide that up, I'm going to go up 1, 2, 3. So I'm going up 3, which means that at some point in my translation I went down 3. So 1, 2, 3, and 1, 2, 3, and 1, 2, 3. Okay, so here's A prime, B prime, C prime. And then right here, I've got 2 intersecting points, and actually right between there is easy because that's going to go right down between those 2 points. So it looks like we have a reflection of x equals -1. Okay, so it went reflection, slide. So we're going to start out with the slide, so that's going to be a translation of, and we went up 3, so that means that apparently we went down 3 to get there. So that's on the horizontal, we're not or on the vertical, we're not moving horizontally, so that's going to be 0, -3, and then a composition with beginning with a reflection over x equals -1. And all of that was on triangle ABC. Okay, so when you are trying to figure out what your glide reflection is, you're going to start it initially. It's going to be reflection, translation, which means that when you write it, it's going to be translation, reflection. Okay, but in order to figure it out, you're going to work backwards. So you're going to translate it back to where it's right across from or right below your original figure, and then figure out what the line in between them would be to figure out the reflection. Okay, now at this point you may want to pause the video and see how many of these questions you can answer without looking at your notes. Okay, and then after you have completely finished, then go ahead and start the video going again and check your answers. Okay, hopefully you have filled that out and we can check your answers now. Another name for a rigid motion is an isometry. A rigid motion keeps the same angle measures and side lengths. The 3 transformations that are rigid motions are reflections, translations, and rotations. And each of those has an AKA. So reflections are also known as a flip. Translations are also known as a slide. And rotations are also known as a turn or spin. And finally, the fourth transformation is a dilation. How did you do? Did you get them all right? Okay, so that's it for now. See you later.